The world around us is made up of tiny little things we call atoms. You can think of these atoms as tiny little balls, and the combinations and interactions of millions of these balls make up everything we can see. These atoms are constantly in motion, spinning, shaking, vibrating, bouncing around. It is this motion of atoms that we call heat. The more motion atoms have, the more excited they are, the more heat they have. When you hit atoms together, they slam into each other, creating a dominoes effect of increased motion. This increased motion is increased heat. You've probably felt this effect before. When you rub your hands together, you're bumping the atoms into each other, jostling them about. The harder and faster you do this, the more motion you give them, the more heat you create.
If you bring something hot, something with very rapidly jiggling atoms, into contact with something cold, something with slower jiggling atoms, the more excited atoms jostle the slower ones, giving some of their motion away. So the faster atoms move a bit slower, while the slower ones move a bit faster. In other words, the hot thing becomes cold, while the cold thing becomes hot. In a liquid, if you cool the atoms enough, they lose so much motion that they can no longer flow past each other, and so become locked into place, simply shaking back and forth. This is what we call a solid. If, on the other hand, you heat the liquid, you can give it so much motion that the atoms simply fly past each other, bouncing around violently, and this is what we call a gas.
Of course, changing the temperature of something isn't the only way to alter its state. When you add heat to water, you allow the parts to move more freely and break away from each other into steam. The reason water is liquid at room temperature is the pressure of the atmosphere is forcing the parts together, unable to break away. If you reduce this pressure, you allow the parts to move more freely and form a steam. This is why water boils at different temperatures at different altitudes. When you add pressure to steam, it turns into a liquid. If you put more pressure on a liquid, you force the atoms into place, stuck, unable to move, and they form a solid.
If you change the pressure on something, you can also change its temperature. In a gas, the atoms are bouncing around with great speed. If you compress these atoms, this motion corresponds to increased bouncing.
And packing more atoms into a tighter space means more pummeling at a greater frequency. As we know, more pummeling means more heat. If you increase the pressure of gas quickly enough, the buildup of heat can be immense.